Okay. So. Okay, start to talk a little bit about linear equations. Okay, linear functions. We've got y equals 2x plus 4. Now, two things we always do when we have a function. We try to find the y value when x is 0. We try to find the x value when y is 0. Gives us at least 2 points on a graph. That not always gives at least 1 point, because we can always find y if x equals 0. That's easy. So if x equals 0, then y equals 2 times 0 plus 4, which is 0 plus 4, which is 4. Okay. Now, what that does is that gives us a point on the graph. Okay, so I'm going to ask you in a minute to sketch a graph and show me the point where y equals 0 and x equals 4. But before we do that, let's answer the harder question. It's not particularly hard in this case because it's a linear equation and it's pretty easy to do. But if you have some of the other equations we're going to see in this course, it can be fairly complicated, even impossible, to answer the question, what's the x value and y is 0? And often there are more than one x value. There's more than one x value. So, okay, so logically, if y equals 0, then if this equation is true, we get 0 equals 2x plus 4, right? And subtract 4 from both sides. I'm going to write it this way: 0 minus 4 equals 2x plus 4 minus 4. And that gives us just 2x on this side. And I'm going to switch sides. I'll put the 2x over here. And equal to negative 4 on this side. So the x, well, write out the steps. 2x over 2 equals negative 4 over 2. And negative 4 over 2 is just negative 2. Okay. So x equals negative 2. Now, sketch me a graph, just hand sketch a quick graph. And let me see if I get this thing to focus, because it was in focus and now it isn't. Where's the paper? Where's my paper? Behind me. Okay, so. Okay, now we're in focus. Okay, so sketch that.
Equal.
Okay. So. What's this tell you? Now, a couple common things. You got to write this out coherently. Write it out the way I'm writing it out. Write out the logic of it. Don't skip steps. And don't do anything in your head. Okay, even if you do it in your head. Write it out the way you'd have to write it out. If this was y equals 47/73 plus 298 over 17. Okay, write it out, because sometimes it is like that, even worse. Yeah, so write it out. Now, once you write it out, what's this tell you? Okay. This calculation tells you that when x equals 0, y equals 4, right? Okay, so when x equals 0, y equals 4, so the point 0, 4 is on the graph. So we put the point 0, 4 on the graph and we label it. Okay, so I'm going to anticipate where it is. I'm going to label this 0, 4. We can call this that's a little hard to read. Combination of chalk and confidence on my part. This is the y-intercept. Okay, so we call it the y-intercept. It's the point where the curve, or in this case, it's going to be a straight curve. It's going to not really curve, it's going to be a straight line. This is the point where the graph of the function hits the y-axis. And if it's a function, it's only going to hit the y-axis in one point. All right. So the other thing we get from down here for y0, x must be -2. Okay, so point -2, 0 is on the graph. Where's -2, 0? Well, it depends on how you scale your graph. But here's the point. -2, 0. Call this the x-intercept. Now, this thing is a straight line. Okay. Now, I'm telling you it's a straight line. I haven't told you why it's a straight line. I just want you to believe me for the moment. It's a straight line. We'll see why. So right there is a straight line through these 2 points. Okay. Now let's estimate on your graph what's the value of y when x equals 1? You got your graph. You can put a scale on it because we have all these numbers. So if this is 4, then you know that 2 is here, and 1 is here, and 3 is here. And if this is -2, right there is -1. So we know that 2 is going to be over here in an equal distance, and 1 is going to be here. Then we can take this scale and we can extend it a little bit. Now, according to your graph, what's it look like y is when x equals 1? Okay. What we do to estimate this, we want to estimate y when x equals 1. Well, if -2 is here, okay, as I said, +2 has to be at an equal distance on the other side. It's not over here, it's not back here, it's not up here, it's right here. Okay, so there's 1, there's 2, there's -1, and here's -2. Okay. Here it's 1, 2, 3, 4 at equal distance. You got 5 and you got 6, right? Your units are the same all the way through. So now if you get a reasonable graph, then you sketch the line where x equals 1. The line x equals 1. That was my problem. Okay, you have to do it in green. Here's x equals 1. And if you're doing an estimate, it would be best if you would label this line x equals 1. Because that gives you a deeper understanding of what the graph is telling you, okay? And you're less likely to miss something important if you actually do this. Okay, then we can do a horizontal projection. Well, here's the point on the graph where x equals 1. And now we draw a horizontal line here and we estimate what the y value is, okay? So this looks like it's about y equals, I mean, there's 4, there's 5, there's 6. My honest estimate is y equals 5.4. Okay? It's not a great estimate. Because you can tell, well now, if x equals 1, what does y equal? Well, 2 times 1 is 2, you add that to 4, you get 6, right? So I got 5.4 when I should have had 6. Okay? Now I've seen estimates of 7, I saw an estimate of 6. Didn't get to look, what was your estimate?
6.
Just, huh? Yeah, you estimated 6, because you cheated, you used a straight edge and everything else, okay? Yeah, I mean, no, you're being precise, okay? It's not quick, but it's precise, and that was a great estimate. Okay. And it's not cheating to use straight edges. It's just, I joke about pulling out drafting instruments and everything else. And I've got people that just can't do it otherwise.
I mean, if
Okay.
it helps.
Okay. Yeah, I mean, I've got a student in another class, it's just totally precise, her notes could be published, okay? And she's just knocking the top off the course because that's the way she has always approached her math, and she actually knows more than what I'm teaching in the course. She was educated somewhere else. Okay. At a place that you wouldn't expect to have a great educational system, but apparently they do. Okay. So anyhow, estimate y when x equals 1. And if you know, if your brain is wired, so you just have to have precision, it's okay. Right? It's not quick. So sometimes you got to be able to do a quick back of envelope thing if you can stand it. But if you're quick with the instruments, yeah, and that's the case here, it works fine. Anyhow, okay, so estimate y when x equals 1. We put 1 in here, and we get 6. So on my estimate, pretty soon I'm going to drop something important. Okay, estimate. Actual. Is y equals 2 times 1 plus 4 equals 6 when x equals 1. Okay. So the graph did a reasonable job of estimating, but of course, the graph gives you the picture. It tells you what everything means. But you plug the numbers into the equation and you get the exact value. Okay. Okay. Another thing, what's the slope of this line? How are we going to get the slope? Well, slope is rise divided by run. Okay. Let's take the point -2, 0. With what? What's the rise? What's the run? And what's the slope? Just kind of write that down for me. Okay, now in my course, I say you need to do what I'm about to do. In this course, you don't, you can use a formula, you can use anything, okay? But to illustrate what the slope is, you got a triangle here, right? Form a triangle from this point to this point. Okay. And if I draw that triangle down here to help me. Run is down here and the rise is up here. So we put a couple of arrows that go from left to right. From the leftmost point to the rightmost point, and the arrow goes this way. And if we're going from here to here, then we got to go up this way. These arrows indicate a path that goes from here to here. Now I can say the run is what? Well, this point here is -2, 0, and this point here is 0, 4. If I'm going from here to here, my x coordinate goes from -2 to 0. Well, the run is then going to be where we end up minus where we start. That would be 0 minus -2, which equals, of course, +2. The rise is where we end up minus where we start is the y coordinate. It's 4 minus 0. The 4 minus 0 equals 4. So the slope is rise over run. And that's 2. And the convention I use that, if you do this in a class other than mine, chances are nobody's going to know what you're talking about. Okay. But if you have this picture, it can be helpful. Now, you don't have to have that picture. You have a formula. Okay. Slope is y2 minus y1 over x2 minus x1. If this is your x2 point, x2, y2 point, and this is your x1, y1 point, and usually the 1 will refer to the point to the left, the 2 will refer to the point to the right. So y2 would be 4, and x and y1 would be 0. Then your formula tells you that's 4 minus 0. You divide by x2 minus x1. Well, x2 is then 0, and y2 is minus 2. 0 minus -2 is 0 plus 2, right? Okay. So you got a minus and negative. And you get 4 over 2. And let me go ahead and put that. That gives us 4. That gives us 0 plus 2 because of the 2 negatives. And that's where we get the 4 over the 2, which is 2, and that's the slope. Okay, so you can see it geometrically. We go from y equals 0 to y equals 4. Your rise is 4. We're going from this point to this point, so the run is from -2 to 0, and that's 2. and your slope is 4/2, which is 2. Okay. So that tells you why the slope is 2. And well, we could use 2 other points in the graph. If we do, the slope is going to be the same, because the graph is a straight line. The slope doesn't change. Now, if we had a little more time, because we got hung up in several things here. If we had a little more time, we'd go ahead and do that. You could use the point 4, 0. 0, 4, sorry. And the point 1, 6. If we did the same thing for 0, 4 and 1, 6. The run goes from 0 to 1. The run is 1. From 4 up to 6, the rise is 2. Slope is rise divided by run, 2/1, that's 2, right? Okay. Well, that illustrates quite a bit about straight lines. There's more. If I give you any value of x, you can find a value of y, which means you can find the coordinates of a point in that graph, right? If I give you any value of y, you can solve and find x, and that gives you a point of the graph. Okay. So I'm going to ask you, I'm going to have to very kind of small, try to write it neatly as I'm capable. Is it even on the screen? Yeah, sure. Okay, find y if x equals 6. And then find x if y equals 40. Okay, so everybody's doing real well. I mean, I looked a minute ago, and when we didn't have the actually out for y equals 40, so be sure to pay attention to that. But everybody got the y, got the value of x if y equals, that's the value of y if x equals 6. Okay, if x equals 6, that's 16. Now, conclusion, and many of you went and, wrote out the conclusion. I didn't ask you to do that, but it's great if you did. That gives you a point on the graph, 16. Okay. Then if y equals 40, then since y equals 2x plus 4, which is what we used there, we're using here again, 40 equals 2x plus 4. So we do 40 minus 4 is 2x plus 4 minus 4. Then you get 36 equals 2x. And then you're going to divide both sides by 2, so you get x. And you get x equals 18. So the point $18.40 on the graph. Okay, so now we could sketch another graph for the function. Okay, well, let's put 16 out here, which we can then divide in half and get 8. Divide that in half, right, that's 4. There's 2, and there's 6. Here's 12. Here's 10, here's 14. And then 18 would be about here. Then we want to go up to at least 18. On the x-axis, let's use a little more room there. Okay, I can put 40 there. Half of 40 is 20. Let's see, break that in half, yeah, it's about there. Then 10 would be about here. Thirty is about here, that's not great, but it's okay. Then 5 would be about here, and so forth. Okay, well, we want to locate 16. Well, sorry, there's 18. We want to locate 16. Well, here's 15. Okay. Now we can plot points. X equals 6 here. Get the thing in the right place. I had a lot of success. Here's x equals 6. We have this. And y should equal 16. Here's 15, here's 20, here's 16. So here's the point. 6, 16. The point 18.40. Here's 18. Here's x equals 18. And here's y equals 40. And here's this point. Now, if I sketch a straight line through these points, something like this, right? Okay. Now that point it was a little too steep. I missed this point. It should have come down a little bit. It's supposed to go through 0, 4, which would be about here. So I kind of missed that point by a little bit. And -2, 0. Well, kind of missed that too. But remember, if I actually hit this point, it'd be plausible that I also hit -2, 0, and 0, 4. Okay. It missed, but it's the same line and the same slope, because let's just do a slope here. Okay, from here to here, here to here. We're going from 6 to 18, so this is 12 units, 6 to 18. And I guess I should. (18 minus 6 equals 12). We're going from 6 to 18, so that's how far we go. Then we're going from 16 up to 40. So we get 40 minus 16 equals 24. Slope is 24 over 12, and that's 12. This would come out very well. But we understand calculation, 24 over 12 equals 2. Look, that's a slope we got every time. Okay, so we understand that any 2 points that we use in the graph, if we draw the graph accurately, has to go through every other point that we found in the graph. Even with drafting instruments, it might be difficult to make it accurate enough to predict something way far away from the 2 points that we have. Okay, so let's look at what some of this is telling us. Okay, the 4. There. That's our y-intercept, right? Because the y-intercept occurs when x equals 0. If x is 0, we get y equals 4. So this is the y-intercept. Now, what's the significance of that 2 in front of x? Okay, so, the other number in this equation is the 2. So when I ask you, what's 2 have to do with this thing? And, prompt a little more, where's 2 keep popping up? And so, oh yeah, it's a slope. Okay, because that's what we just calculated. We calculated the slope of 2 here, calculated the slope of 2 here, and we calculated the slope of 2. And we did this. So this is the slope. So in general, the equation of a straight line looks like this. We write it y equals mx plus b. That's pretty universal, at least in English, okay? Almost any textbook you see tells you that's the standard equation in a straight line, okay? For m, is the slope. When any pair of points. And b is a y-intercept. Or if we call the y-intercept a point, the point 0b is the y-intercept. Okay, so we've seen that for this equation. Now, Find the x and y intercepts of this equation, 4x plus 12y equals 24. Okay. So people did well with this. X equals 0, then four times 0 plus 12y equals 24. So that y is 24. And y equals 12 over 24, which is 2. Okay, so we have the point. Zero, 2. Okay. Now, if y equals 0, we get 4x plus 12 times 0 equals 24, so that 4x is 24. But x is 24 over 4, which is 6. And now we have the point, y is 0, x is 6. So x is 6, y is 0. Now we can draw a graph. Here we've got the point 6, 0. There's the x-intercept. 0, 2. There's the y-intercept. There's our graph. If it's a straight line. Well, this is a straight line because we can do a little algebra and put it in the form y equals mx plus b. Okay. So we haven't proved it's a straight line. I just drew a straight line, so it is. I haven't proved it, but I'm gonna ask you to prove it. Okay, so. Prove that the graph of 4x plus 12y equals 24 is a straight line. Do that. We're going to solve that equation for y. Okay, now people are having trouble getting started in this for the most part. What we're trying to do is we're trying to isolate y. You know, just off to the side here, let's say we had 8 plus 12y plus 24. What would we do to both sides to start solving this for y? Okay, if we had this, which we don't, we can't put numbers in here that don't go along with the actual solution. But if we have this, we'd want to get rid of that 8, wouldn't we? And we get rid of that 8 by subtracting it from both sides. So you might want to write it, okay, expand the equation, -8 equals -8. And you get 12y equals 16, okay? Okay, we could do that. Now, we don't do that because this isn't 8, it's 4x, but we're gonna do the same thing with 4x that we did with 8. We're trying to solve for y, we're trying to isolate y over here, so we can subtract 4x on both sides. And well, let's do it this way, because most people like to see it this way. There it is. Well, if we subtract 4x minus 4x is what? Show me with your fingers. 0, right? There we go, that. So we get 12y equals 24 minus 4x. Okay. Then we divide both sides by 12. That'll give us y. So we do this. Okay. Well, 12y over 12 is just y. Now be careful here. People often want to divide the 12 into the 24. You can cross out the 12 and the 24, cancel, and end up with a 2 here. Okay? You can't do that unless you do that to this one too. Because 12 is divided into both of these. It's a distributive law. It's like you multiply by 1/12. You got to take 1/12 for this and 1/12 for this. So we could write that as 24 over 12 minus 4x over 12. Okay. And then we're out of time. So we're going to get 2 minus 12, 4 12 is 1/3, right? I'm going to write it this way. Okay. So now tell me, is this in the form y equals mx plus b? Well, it is. You've got an mx, you got a negative 1/3 x, right? And you've got a b, which is 2. But if you like, we can put it in order. Okay. I would say y is negative 1/3 x plus 2. And here's m. It's y equals mx plus b. M is negative 1/3. And b is 2. Now what's b? B is the y-intercept. Look at the graph we just did. What's the y-intercept? 0, 2. Okay, so it has the right intercept. What's the slope of this graph? If we just use these 2 points, the rise is negative 2. The run is 6. Slope is negative 2 over 6. Which is negative 1/3. Okay. So what we've done is we've started with this equation. We found the y-intercept. We let x equal 0. We find y. That's going to be our y-intercept because x is 0. We find that y equals 2. So we have the point 0, 2, and that is our y-intercept. We've got the point. Well, if we find x of y is 0, y is 0. Plug in and we get x equals 6. We have the point 0, 6, 0. Okay. And then I said, well, this thing's a straight line. Okay. But I asked you to then prove it by solving the equation for y and showing it's in the form y equals mx plus b. Well, that's apparently a bit of a challenging solution, but you can follow every step. And you can verify every step. So we've shown that this thing is in the form y equals mx plus b. And since I said, haven't proven it, but I've said that y equals mx plus b is always the equation of a straight line. Then we know this is a straight line. Since we know the two intercept, then I was justified in drawing a straight line through those 2 points. Okay. And if you understand that, pretty good start on understanding linear functions.